Hello, my dear students of class 11. Today we will be discussing about isomerism. So in class 10, you were taught what is isomerism. So here is a recapitulation for you. Isomerism, what does it mean? Whenever you have a molecular formula, but it can give you different structures. Okay, with the same molecular formula, if you are able to write more than one structure, that is two or more structure, then these structures are known as what? Isomers, and this phenomenon is known as what? Isomerism. So that is the basic definition. So in class 10 we have discussed about chain isomerism and position isomerism. I hope you still remember it. If you don't remember it, today we will be discussing isomerism in more detail. Please listen to it carefully. Okay? So, isomerism is broadly classified into two categories. The first is structural isomerism. Structural isomerism. The other one is stereo isomerism. Okay, now this structural isomerism is further classified into different types. Now the first is chain isomerism. The second is position isomerism. The third is functional isomerism. Then comes metamerism. Then we have ring chain isomerism. Then last we have Tautomerism. So structural isomerism is again classified into 6 different types. Chain isomerism, hope you know it, we have discussed in class 10. Position isomerism also. Functional metamerism, then we have ring chain isomerism, and then tautomerism. So let's discuss this one first. Okay? After having discussion on structural isomerism and its type, then we will move to this part, stereo isomerism. So we are going to discuss about chain isomerism first. So what is chain isomerism? So chain isomerism means number 1. So chain isomerism means you have the same molecular formula, but it will have different structures depending which varies in the chain length. For example, if I give you an example, it will be clear. So suppose you have C4H10. This C4H10 is what? Alkane. So with this, you can either have all of these 4 carbons in a straight chain, or they could be branching. Now instead of having 4 carbons in a straight chain, we can have 3 carbons in a straight chain and then 1 branching. Okay? Now feel the valency of this each carbon. Here 3 hydrogen, here 2 hydrogen, here 2 hydrogen, and here 3. So you have 4 carbon and 6 plus 4 is 10 hydrogen. So with this molecular formula, we can write this structure. Or here also we have this 3 hydrogen, here 3 hydrogen, 3, and here 1 hydrogen, because the valency of carbon is 4. It has to form 4 bonds. Now see, with the same molecular formula, instead of having this structure, we can also have this structure. We can also have what? This structure where this two, it varies in what? Chain length. Here the name of this compound will be 1, 2, 3, 4. So 4 means bute, and all single bond butane. Whereas the same molecular formula can have this compound with the numbering of carbon in a square chain is only 3. This CS3 is as what? Prefix. So the name of this compound would be 2-methyl. 3 carbons in a square chain, that is prop N. That is what? 2-methyl propane. Sorry for the disturbance. Now, so these two are known as what? They are known as chain isomers of each other. Why? Because they are going to vary in the chain length. Now let's discuss about the second one, that is the position isomerism. Okay, the second one is position isomerism. Chain isomerism we have first discussed. Now let's discuss about position isomerism. Position isomerism. Now this isomerism varies. This isomerism is mostly found in compounds having multiple bonding, or they have multiple bonding, or they have a functional group. So let's take an example. So let's consider the molecular formula C4H8. Now C4H8 is what? C4H8 is, it's an alkene, that means it has double bond. Now this alkene, this write two structures of alkene. Now here the double bond would be present here, or it could be present between these two carbons. That means carbon number 1, 2, 3, 4. 1, 2, 3, 4. So here you can see that the double bond is present between carbon number 1 and carbon 2. But here in this structure, the double bond is present between carbon number 2 and carbon number 3. Therefore, now this differences in position of double bond in these compounds will give rise to what? Position isomerism. Okay? Now, let's feel the valency of each carbon. CS3. So 3, 6, 7, 8. Here we have CS3. This has only 3 bonds, 1 bond and 1 bond. Okay? What would be the name of this compound? The name of this compound would be but. The name of this compound would be but1E, because the double bond is present at carbon number 1. Here the name of this compound would be but at 2E. Okay? Hope this is clear. Now let's discuss about the next type of isomerism. That is functional isomerism. Now, in functional isomerism, what we can do is, with the same molecular formula, we can have two different compounds with different functional group. Okay? Now, such compounds where from the same molecular formula we can write two structures with two different functional groups. Then that is known as what? They are known as functional isomers, and this phenomenon is known as what? Functional isomerism. So let's take an example. C2H6O. With this molecular formula, okay? With this molecular formula, you can have this structure where you have OH functional group, your hydrogen, and hydrogen. You can count the number of carbon, 2 carbon, 5 plus 1, 6, and oxygen. So, with this molecular formula, we can have this structure, or we can also have the structure where we have oxygen joining to alkyl groups. Okay? You can count the number of carbons. It is exactly equal to the carbon, oxygen, and hydrogen is exactly matching with the molecular formula. Okay, so you saw that with this molecular formula we can have two different structures, but most important thing is what here the functional groups are what different. This is OH, which means alcohol, and here this O is present and it is going to alcohol, and this such compounds is known as what ether. Such compounds are known as ether. So this is an example of functional isomerism. Now let's move on to the next type of isomerism, that is metamerism. Metamerism. What is metamerism? So here in such type of isomerism, what we see is that we see like in ether we have two sides. You have such compounds where you have R and R. Yes. So here there is difference in the number of carbons which are attached to this alkyl group. Okay, this is ether. Just now we saw the example ether. Now this metamerism is mostly found in compounds of ether. Let's take this example where we have say CH3, CH2, CH2, O, and say suppose you have CH3. Okay. Now here how many carbons are there? 1, 2, 3, 4. 4 carbon. How many hydrogens? 3, 6, 7, 8, 9, 10, and 1 oxygen. So this is the molecular formula. With this molecular formula, you can have this structure, or you can also have a structure where you have CH3, CH2, this side, and here also you have CH2, CH3. So now count the number of carbons, hydrogen and oxygen, it exactly matches this molecular formula. What is the difference between these two? You can see that the difference is in the length of alkyl group. Here 2 carbons are present, 1, 2, 3, but here you have only 2 carbons. But these two are derived from the same molecular formula. Therefore, they are now known as what? They are known as metamers, and this phenomenon by which they show this isomerism is known as what? Metamerism. So here you have to remember that this differences in the number of carbon in the alkyl group part of the ether. Here you have 5. Here you have how many carbons? 2 carbons. Here you have 3 carbons. This side you have 1 carbon, but here again you have 2 carbon. Okay, so you have to remember this. Now let's discuss the next type, that is ring chain isomerism. Isomerism. Now in this ring chain isomerism, this topic itself tells us about what type of isomers are there. One will be staying in the ring form, the other one will be staying in the chain form. So let's take an example. So here, this is not a triangle, okay? Please remember. In mathematics, it's triangle, but whenever you're writing this name of this organic compound, it is different. It has a different meaning. Now this means CH2, okay? And they are all staying in a closed form. This is the ring form. Now, with the same formula, now what will be its molecular formula? Molecular formula will be C3H6. Now with this molecular formula, you can have this structure, or you can also have structure. Let's take three carbons. You can have double bond here, CH2, one H here, and here CH3. So with the same molecular formula, you can have a compound staying in ring form, the other one in the chain form. Such isomers are known as what? Ring chain isomers, and this phenomenon is known as what? Ring chain isomerism. Okay. Now let's discuss the last type of structural isomerism, that is tautomerism. That is what? That is tautomerism. Now we are going to discuss about what? Tautomerism. Now this is the sixth type of structural isomerism. This is the sixth. Tautomerism. Now this is a little different from other types of structural isomerism. Here also, with the same molecular formula, you will be having two different compounds. Okay? But now here you have to listen carefully. These two different structures, which are tautomers, if they have to be tautomers, they have to stay in dynamic equilibrium. Do you understand by dynamic equilibrium? Dynamic equilibrium means this one form will be converted to the other form. Okay? And this form is also at the same time is converting to this form. That means there is a reversible sign. Okay, so tautomerism are those isomerism where you have with the same molecular formula you will be able to write two different structures and they are going to stay in dynamic equilibrium. For example, if you have this compound, say you have CH3, C double bond O H. Okay? Now, these are reversible. Please remember this. Tautomers, they are in dynamic equilibrium. Now, what will happen is one of the hydrogen from here can be shifted here so that you can have CH2, CO, H, H. Now, here you can see that this is aldehyde. That means it's the carbonyl group. Okay? So, this is keto form. And here you can see that this OH is present. OH is what? Alcohol. And this is known as enol. So these two are known as keto-enol tautomerism, and don't forget these two are in dynamic equilibrium. Okay? So what did you see? You saw one functional form of the compound going to the other one. Here you have a different functional group, that is alcohol. Now at the same time, this form is also going to the keto form. And to tell it approximately, this forward reaction is more compared to the backward reaction because this is more stable form. So more amount of it will be converting to this, but some of it will also be converting to this form. Okay, this is known as dynamic equilibrium. Now, tautomerism. So since we have finished discussing about structural isomerism, so here you have to remember the definition and the examples. Okay, so all the 6 different types of structural isomerism. In our next video, we will be discussing about stereoisomerism. Thank you.